Okay, so this question we can learn from the last question. We also given one trigonometric ratio. This time is cos alpha equals negative 4 over 5. Now we can tell right away. So the alpha angle is in second or third quadrant. Okay, and then to find out the other trigonometric ratios, so we need to figure out the triangle formed by the reference angle. So let's find out the reference angle first. So first of all, let's draw the angle diagram. So the terminal arm is going to be terminal arm is going to be like this, 4 over 5. So it should be like this. Okay, and third quadrant as well. Okay, so the angle could be this. So let's label the alpha 1, or this, labeled alpha 2. But the reference angle is going to be the same, right? Because the reference angle is determined by the absolute value of this ratio given. So they're going to be the same. So first of all, we need to find out the reference, the triangle, construct this triangle so that we can have better idea of finding the other ratio. Okay, I'm just gonna do one because the other one is symmetrical. It's about the same. And 90 degree. So now again, because the ratio is negative 4 over 5, so we can simply make this point like negative 4. Sorry, negative 5. It is negative 4. And then how much is this? For now, we don't really know. But we know the hypotenuse is 5. Okay, and actually, if you know the Pythagorean triplet, so we can find out the y here, right? So the y, we can use y should equal square root 5 is the hypotenuse minus the 4 squared. We should get 3. So the y should be equal to 3, right? I didn't actually draw this to scale, so the y is actually smaller than the x. And then since we already got everything in this triangle formed by the reference angle, so you can find out this other ratio right away. Okay, so for alpha 1, which is in the second quadrant, and then we can find out the sine alpha 1 should equal y over r equals 5, right? So it's positive, y equals positive 3, so it equals 3 over 5. And then tangent alpha 1 equals opposite, which is 3 to adjacent, which is -4, so it should get -3/4. Okay, and then for R for 2, that's in the third quadrant. Normally we call it quadrant 3. And then if you're not sure, you can also, draw this triangle again. Right? So here, of course, like this. So this is y here. It should equals -3. Just be careful. Okay. So that's why the cos alpha 2 is also negative, because the x is negative. Sorry, I made a mistake. So the y is still positive. Y is -3. Okay, that's true, but it doesn't matter about the cos. So because as long as x is equals -4, the cos is always negative. Okay, and then we just do sine alpha 2. It's supposed to be opposite to the uh, hypotenuse 5, so it should be -3/5. So different from the sine alpha 1. And then the tangent alpha 2 is going to be -3/-4, and then both negative, it becomes positive 3/4. Okay, and that's A. For the B, because we can find out the reference angle, so find out the reference alpha 1. Sorry, the reference angle. Reference angle alpha, which is called theta reference. And this one should be, we can use any of this ratio. Let's use cos -1 4/5. Now, again, I didn't put a negative. This one should be 37 degree. And since you get the reference angle, I can easily tell the alpha 1 is 180 minus the reference angle. It's gonna be 143 degree. And the alpha 2 is in the third quadrant. It should be 180 plus the reference angle. It's gonna be 213 degree. Okay.